This is Module 1, Part B. So a reminder of the topics covered in Module 1 and those outcomes, defining the level of efforts for commercial building energy audits. We're going to talk more about that in this Part B. We did some work on calculating the EUI and the ECI also. And in this module, I'm going to go over about benchmarking. And then coming up, we'll identify data collection methods and something about determining what end use is in commercial buildings. So ASHRAE identifies 3 levels of effort and then something called targeted audits. And we'll look at each one of these in a little more detail. And just a reminder that prior to doing any of these levels of effort, what the auditor will do is they will look at the historic utility bills and do an analysis of what their energy use is, and that was discussed in Module 1A. So let's talk about a Level 1 energy audit. Very common. Sometimes people call this the walkthrough survey. The first thing you're going to do, of course, even before you go out to the site, is you're going to collect your utility data, and you're going to try to determine the energy cost index and the energy utilization index. When you get more experience, you will understand the value of, especially an EUI. If you have a facility that's an office building and it has a relatively high EUI, then that gives you a clue to the fact that, hey, this building might be in need of some improvements. If it's already performing really well, then you might have to look a little deeper. So the EUI is a very good calculation. The next thing you're going to do is you're going to go on site and you're going to walk through the walkthrough survey. That includes meeting with the owner. You're going to do a space function analysis, and what that means is you're just going to identify what kind of spaces you have. For instance, you'll look at this has classrooms, certain percentage of classrooms. It might have offices. So you sort of carve out what this building does, and usually a plan is in place. Like when I say plan, an architectural plan and or maybe even a table to sort of figure out how this building is being functionally used. Then you will identify any low cost or no cost or O&M improvements. O&M stands for operation and maintenance improvements. And this is the first place that energy auditors go looking for energy savings. For instance, scheduling of equipment. Does the equipment turn off when the people aren't there? That's a low cost, no cost operational and maintenance improvement. You're going to do an estimate of the approximate savings and then identify any potential capital improvements. And that usually comes directly from the owner. They may say, we are considering upgrading our HVAC equipment. We are considering adding PV solar to the roof. Those are capital type improvements. And so you'll identify those. The next level of effort in conducting an energy audit is level 2. This level includes all the work that you would do at a level 1 plus a little bit more. An important aspect about level 2 is that you need to identify and review the major energy using systems, which are electrical, that includes lighting and power, and the mechanical, which is HVAC and refrigeration. You'll also identify the other systems, domestic hot water, kitchen and laundry if it's there, any pools or spas, large gathering area, and also the plug or process loads. What I have here is taken from a report of a recent level 2 audit that I conducted, and I want to illustrate how we organized the mechanical equipment by the systems, the air handling units, the boilers, the chillers, and the pumps. And we put them into an organization, and this is what ended up in the report in a format that's easy for the client to read and also provides significant information. It's also to review how the facility is operated and maintained. By operating, we want to know what are the set points for the heating, the cooling, the chilled water set point, the heating hot water set point, All those set points, where is the facility's equipment being set to try to maintain? We also want to look at maintenance procedures and practices. How often are filters changed? Do economizers work, and are they maintained, and do people know that? The other thing that's really important is scheduling. What is the scheduling of the personnel in the facility? And does the equipment scheduling match the occupancy schedule? And we find that that's a really important aspect of it. Do the lights turn off when they need to? Does the equipment air conditioning system set back during occupied periods? Do fans turn off when they're not needed? That kind of thing. Collecting the data for an energy audit is site specific. Every facility is going to have different mechanical equipment, different schedules, different functions, and personnel. In the back of the procedures handbook are a number of sample forms that encompass just about any application that the energy auditor would entail and come upon, and how to collect information for each type of application. Those sample forms start on page 98 and continue to page 137. I'm not going to reproduce them here. If you buy the handbook online, then these sample forms also are available in a downloadable format. A very important aspect of the Level 2 energy audit is the inclusion of energy efficiency measures, identifying them and calculating savings. Energy efficiency measures, the acronym being EEM, is a collection of actions and equipment installations that are intended to reduce the building's on-site energy use while at the same time maintaining or improving the indoor air quality, the service, and operating requirements. Recommended EEMs will result in economic benefits, primarily through reduced energy costs, and they may also result in operation maintenance cost savings. Auditing engineers are going to look for the low cost, no cost measures first. These could be as simple as scheduling of equipment or lighting. Does the equipment turn off when it's not in use? The other is optimization of HVAC controls. This is a little bit more subtle and takes a knowledge about the HVAC system, but it can result in significant energy savings for very little cost. There are 4 opportunities that energy auditing engineers always look for when trying to find the low cost, no cost energy savings. The first one is scheduling, turning things off when they don't need to be on. The other one is sensor error. A lot of the controls rely heavily upon sensors to send information to control some system appropriately. And if the sensor is not working or not calibrated, then it will be sending incorrect information and the system will not be running correctly. Next is the use of outside air. Buildings, commercial buildings, use outside air for typically 2 purposes. The first one is for ventilation. And in ventilation, what the outside air is doing, its intent is to displace indoor polluted air. For instance, off-gassing from carpets or respiration from people. That is an indoor air pollutant, and the outdoor air is used to displace that, get it out through the exhaust system. The other use of outside air is for free cooling. If the building interior needs cooling and the outside air conditions are appropriate to do so, then the system is designed to introduce outside air for cooling and not do mechanical cooling. Both of these applications for the use of outside air are engineered to be precise. We don't want too much outside air coming into our facility. If so, if too much outside air is coming in, say in the wintertime, then I have to heat that air up. And of course, in the summertime, I have to cool it down. So outside air needs to be controlled very precisely. The last opportunity that auditing engineers always look for is something called simultaneous heating and cooling. A lot of systems are designed to do exactly that, to cool and heat at the same time. Why would that happen? Well, VAV systems do reheat, and dehumidification systems. A dehumidification system is where we cool the air down to allow much of the moisture to condense out of the airstream, but that may result in too cold of air, and so we have to heat it back up. But if the simultaneous heating and cooling is not controlled appropriately, then the system will be running inefficiently. Calculating the energy savings is not a minor task and really takes years and years of working in the industry to become proficient at doing so. But that is one of the goals of the Level 2 audit and the auditing engineer, is to calculate the energy savings, the energy cost savings, and of course what a simple payback would be if implementing that measure. The Level 3 energy audit is going to be a detailed analysis. It's going to include the work that the energy engineer performed in levels 1 and 2. But in addition, the energy savings for the energy efficiency measures is going to be much more detailed. It may include energy modeling that will do a calculation for all hours of the year, say 8760 hourly savings calculation, such as done by eQuest or some of the other more sophisticated energy modeling software. And for pricing information, the estimate needs to come from a contractor. It needs to be a firm price. And instead of doing a simple payback, the auditing engineer will perform a complete life cycle cost analysis for each measure. Of these three levels, levels 1, 2, and 3, level 1 is very common, a quick walkthrough, and that gives the owner and the auditing engineer sort of a broad picture. It's like, does this facility have plenty of opportunities, or is it running fairly efficiently already? Level 2 is probably the most common. And then level 3 is going to be reserved for those facilities that need that detailed analysis. A targeted energy audit is an assessment of a specific system or end use at a facility, whereas the level 1, 2, and 3 audits provide a comprehensive approach to energy savings of the entire facility. A targeted audit focuses more narrowly on an area of a particular interest to a customer. For instance, a building with a chiller at the end of its useful life may want to take advantage of the need for the replacement to investigate energy efficiency options, sizing specifications, and other alternative strategies. Energy end use is simply separating the energy cost and use allocation into separate categories. So what I've shown here is the utility data that we had in Module 1A. And the pie chart there shows that the percentage of the total annual cost into different categories. So for instance, the kilowatt hours is 50% of the cost for that year for that facility. Natural gas is about 34%, and they spend about 16% on demand, electrical demand. Another useful tool, but beyond the scope of this course, but something I wanted to show you, is subdividing the energy end uses into more specific categories. In this case, we took an energy audit and we took the utility data, and then using some data from other resources, we were able to allocate where the energy use goes by usage. For instance, space heating, space cooling, auxiliary hot water lighting, and the miscellaneous, and put it into a pie chart like this and into a table such as this. This is beyond the scope of the work, but it's also discussed in the procedures book on pages 32 and 33. Now let's talk about benchmarking. A benchmark is a standard by which something can be measured. So once you have calculated the EUI for your facility, you use it to benchmark your building. Benchmarking allows you to compare the energy performance against similar facilities or an established level of performance. In order to benchmark, it's very important that you compare apples to apples. It will do no good to benchmark a building in California against data based on a building in Colorado or Oregon. Energy Star Portfolio Manager is used as a popular benchmark for commercial buildings. Here is the link to the Energy Star website. I've created this assignment 1B, to give you the opportunity to experience using Portfolio Manager for an office building. This assignment, you'll use the data that you used in Module 1A to calculate the energy use intensity, EUI, and ECI, and you'll compare that with what is given with Portfolio Manager, and then also see some of the other information that it provides. There are many ways to get to the Energy Star Portfolio Manager. So if you Google Energy Star Portfolio Manager, you'll probably get something like this. And you can go to this login, energystar.gov, or this one right here. It doesn't really matter. Let's go down here to Portfolio Manager Login Energy Star. When you go there, you'll see a page like this. We're talking about commercial buildings and benchmarking, and then here's the Getting Started link. And what you'll need to do is, the first thing you need to do, probably, is you need to set up your own account in Portfolio Manager. This also, find out what data you'll need to benchmark. I've given you all the data that you need, but feel free to look around the website here. Also over here, there's the benchmarking starter kit, data collection worksheet, quick start, and then there's more training available if you are interested. So for assignment 1B, you will create a login for yourself, and you'll get something like this. This is my login. As you can see, I've done a number of different facilities over the years, and they keep it for me. But let's if you click on this one right here, what you'll see is something like this. It has some information for it. It has a score of 78. Let's look at some details. Let's look at energy. Here's, I put in the utility data, and this is what I got. It's not going to get an Energy Star certification for whatever reason. I have an electric meter and a natural gas meter, which is what you'll have. And I'll show you how to generate this information. So for your assignment 1B, what you'll do is you will add a property. Click on this button here, and that will take you to this location. Your property type, what you're going to type in, when you click on this box, you're going to search for and click on an office. We're going to keep it simple, an office. And your property's buildings, how many physical buildings do you consider? We just have one, very simple. And the construction status, it's existing. And then go down here and get started. And again, there's all sorts of information that if you're interested, you can click on any of these buttons here. And this is what you'll get. I've given you all the information you need for this. The name is your unique name. You can call it office building sample or whatever you want to call it. And I believe I've given you all the information to fill in here. You'll select Oregon. I've given you the postal code, the year it's built, the square footage area. The irrigation area, you'll click 0. There's no irrigation. And for occupancy, select 100%. We're going to assume that it's 100% occupied. So you'll click on this right here and click 100%. No photo for this, and skip the standard IDs. And do any of these apply? And we're gonna assume that no, none of these apply, and you'll hit continue. Now, once you have all your data in, you hit continue. This is going to tell me I have a whole lot of things missing, because I do, but hopefully when you hit continue, you'll get a different screen. So here's what you'll end up typing in. Give it a name that means something to you. The country is the United States. Here's the address that is given the assignment. It's in Portland. It's Multnomah County. All this is given in assignment 1B, Oregon. Here's the zip code, the year it was built, the square footage, no irrigation, and it's 100% occupied. So you'll type in all of this. So now you've filled in that information. We're not going to do anything with standard IDs. Do any of these apply? No, and so hit continue, and this will take you to this page here. Your basic information shows up here as we typed it in. The building use, And now, just scrolling down, we have 49,111 square foot. And we'll go ahead and use the defaults for all of this information right here. You could fill it in if you had that information, but for this assignment, just assume the defaults. Since we use the defaults, we get this pop-up that says, if you do not enter values for your property use details, Portfolio Manager will calculate default values on your behalf, but then you won't get an Energy Star certification. That's okay for us. So now here we are, and we've successfully created our property, and now we need to add energy use. Since we have no data, since we haven't entered any, but now let's go to this energy tab here, and we're going to have 2 meters. We're going to add a meter. And we're going to add an electric meter purchased from the grid. We have one of those. We're going to add natural gas. We have one of those. We don't have any of these other types of meters. So we have an electric meter and a natural gas meter. And let's get started. So now we're on this page, 2 energy meters for sample. Remember, you'll have some name here. So if we click on this one, the units we're going to use here are going to be therms, because that's our utility data is in therms. And the date the meter became active, go ahead, and what I suggest you do is do January 2025, that date. And it's in use. And we can create that meter. Let's create the electric meter. That's going to be in kilowatt hours. That's what our data is in. And again, we're going to start that because our data is going to be for the year of January 2025, and it's in use. So let's create those meters. So the other button you want to click on is this one right here. These meters account for the total energy consumption for your building. Hit Apply Selections. So now we need to enter our bills for our meters. So let's click on Enter Your Bills. And this is our electric meter, monthly entries. So we'll click here to add an entry, and we're going to start with January 2025. So January 1st, 2025. So that's our first month of bills. And you're going to enter the kilowatt hours, the cost for kilowatt hours, the demand, and the demand cost. And that is from assignment 1A. And as a reminder, this is the utility data that you will be entering. This is your electric data for your electric meter, and this is your natural gas data. Up here, you have the opportunity to select which meter to enter data for. We have the electric meter, or we have the natural gas meter, and you need to fill out the data for both. I don't have any data entered. That's what you're going to do. And when you're done, you're going to select Slave Bills. Now, display years, what's going to happen here is this Show All Years. Let's see what happens. Years to display. We haven't displayed any, but when you get done, you'll see Show All Years, and 2025 will show up here. Once you're all done, once you've successfully entered all your data, you'll be able to click on this tab here, Energy, and you'll get the energy use as shown here, which I've done. I've entered the data for the electric meter and the natural gas meter, and then these are the details that we entered. And it will calculate an Energy Star score. We know that it's not eligible because we didn't put in all the detail for that. But then what you can do is you can go to this tab here called Reporting, and you can get your Energy Star scorecard, which you'll print out for this property. I didn't finish out sample, but this one I put in. Let's do this one here. So generate reports. This is a different project that I did, and you'll get something that looks like this. So for the assignment for this office building, you will generate an Energy Star scorecard and a statement of energy performance. Here's a scorecard that I did for something called the Justice Building in Salem, Oregon, a few years ago. And the scorecard shows that it's 89 out of 100, 100 being most efficient. Anything less than 50 is not very efficient. And that's what the benchmarking tells us. If you do an energy audit and you look at utility data and you get a score that's fairly low down in here, then that shows the fact that this building can undergo a lot of improvement. And they also show the energy used per square foot. This one has 43 kBTU per square foot per year. The building that you're doing is probably going to be somewhere, this is going to be high and the score is going to be a lot lower. And that's the conclusion of Module 1, Part B.